Okay guys, so today we're going to be looking at subtracting integers. So we've done adding integers, and so now we're going to look at subtracting them. And when we subtract integers, really the goal is to get it to adding so that we can follow our adding rules. So just a reminder of our adding rules, that when the signs are the same, so if the signs are the same, what do we do? So like, for example, if I have -4 plus -6, if my signs are the same, negative and negative, I'm going to add them together and then keep the sign. So I would keep negative, and I'd go 4 plus 6 is 10, so my answer would be -10. Now, if my signs are different, so let's say I have -4 plus +6, then I'm going to end up subtracting the two. So I would end up doing 6 minus 4 is 2, and keeping the sign of the larger absolute value. So the absolute value of -4 is 4, and the absolute value of 6 is 6. So 6 had the greatest absolute value, and it was positive, so my answer is going to be positive. So as we remember those, we need to keep those in mind when we're subtracting. But what I want to do when we're talking about subtracting integers is first we're going to do a modeling, just like what we did with the counters when we were adding. So as a reminder, I'm going to get my little counters out here. Okay. So my yellow equals a +1, and a red equals a -1. So that's just our little key to remember. We call these zero pairs, because what I mean by that is when you have a +1 and a -1, they cancel out. They're each other's additive inverse. So +1 and a -1, when combined together, they cancel out to equal 0. So that's important to remember. Okay, so starting off, looking at your notes, at your 1.4 notes, you see this table, this chart right here. And they've already filled out the first one for you. This is like first grade math. 4 subtract 2. What are we doing here? We're subtracting 2 positives, which ends up giving me 2. Well, I could model that here as well. So if I have +4, so 4 yellow counters, plus 2 negative counters, I'm going to look at and see what 0 pairs I have to cancel out. So this is a 0 pair, and this is a 0 pair. So that leaves me with 2 positive. So notice that this subtracting was the same as adding a negative. So let's see if that pattern continues. So I have -3, 1, 2, 3, and I'm taking away a +1. Let me write it here too so that we see what's going on. We have a -3, take away a +1. Well, I can't take, in our model, I can't take a positive away because I don't have any positive counters. So I'm going to need to put some positive counters here without changing this expression. So what I can do is, here's my positive, but every time I add a positive, I got to add a negative with it, so that, remember that these two right here make a 0 pair, and they actually cancel each other out. So now that I have a +1 that I can take away, I'm left with 1, 2, 3, 4 negatives. So -4. Okay, so we're going to remember that. In our next problem, we have -3 plus -1. So I'm going to model that. We've got 1, 2, 3, plus a -1. what I've done is 1, 2, 3, 4. I also get negative 4. You notice we end up doing the same thing. Subtracting is the same thing as adding a negative. Let's try it again. And we need to be filling this out as we go, okay? So I have 3 take away 8. So 3 take away 8. So positive 3, so 3 yellows, 1, 2, 3. And I need to be able to take away 8 positives. But I don't have 8 positives to take away. All I have are 3 positives to take away. So I'm going to need to add 5 more positives to make a total of 8, right? So 1, 2, 3, 4, 5. But that changes the whole problem. So what I have to do is I can't just add the positives. I got to add in the negatives. Because if we looked at this, it's like we actually didn't add anything because this is 0, 0, 0, 0, 0. They cancel all out. So it's like we didn't add anything. So now I can take away 8 positives. So 3, 4, 5, 6, 7, 8. So I'm left with 1, 2, 3, 4, 5 negatives. Okay. Our next one, instead of subtracting 8, we're adding negative 8. And we're going to see what the answer gets here. So I've got my 1, 2, 3 positives, and I'm adding 8 negatives. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8 negatives. And because of 0 pairs and additive inverse, those cancel, and those cancel, leaving me with 1, 2, 3, 4, 5, negative 5, which is the same answer that we get here. So what I'm going to have you do is, using your notes, I want you to finish these last problems right here and fill out your chart. So I want you to pause this and do that. Alright, now that we've done that, what we have noticed is, if we go back and look at our chart, what we've noticed is that when we are subtracting a positive, what we're actually doing is we're adding a negative. So when we go to subtract integers, what we're going to do is we're going to change subtraction to adding, okay? And we're going to change the sign of the second term. And I understand that that kind of, by wording, looks funny, and we may not understand what that means. But we're going to see on the next page some examples of what these rules are. So our rule is we're going to change subtraction to addition, and we're going to change the sign of the second one, and then we can just follow our rules of adding integers. Okay, so if we look here, our directions say to use number lines. We're not going to use number lines right now, we're just going to use the rule. And we can use counters to check if we want to. But here I have negative 2 minus 4. What we're going to do, and I'm going to change this to a different color so we can see what's happening, is we're going to change this subtraction to addition, and then we're going to change the sign of the second one from positive to a negative. So now we have negative 2 plus negative 4. And then we can follow the rules of adding integers. Because they're the same signs, we have negative and a negative, if they're the same, we add. So I'm going to add 2 plus 4 is 6, keep my sign, my answer is negative 6. But what does that look like in the form of using counters? What was that? How could I model that? So if I have 2 negatives and I'm trying to take away 4 positives, I don't have 4 positives to take away. I'm going to need 4 positives. So to get 4 positives, I have to add a negative for every positive so that those would cancel out so that we're not actually changing the equation. Because when we look at this, we still have negative 2, okay? And that this part over here is equivalent to 0. But now I can take 4 positives away. 1, 2, 3, 4. And I'm left with 1, 2, 3, 4, 5, 6 negatives, which is the answer that we got. Alright, hold on with me. I promise it's not, it gets better, I promise. So we have negative 3 minus negative 7. We're going to change to addition, change the sign of the second term. Now we're going to follow our rules. Remember, our rules are if they are the same sign, we add. If they're the different sign, we subtract. So looking at our signs here, we have a negative and a positive. So we have different signs. So different signs say I'm going to subtract. So I'm going to take the largest absolute value, 7, and subtract 3. I'm going to get 4. To decide what sign it is, we have to look and see, well, let me change this so it doesn't confuse us. Which number or which absolute value is greater, and that's the sign that we keep. Well, 7 is bigger, and it's positive, so we're keeping the answer as 4. When we change subtraction to addition, we forget about that problem, and we only focus on that one right there. Okay? All right, let's keep scrolling and see how we're feeling. So we have 1 take away 4. We're going to change to addition and change the sign. Are our signs same or different? They're different because we have a positive and we have a negative. And if they're different, we subtract. So 4 minus 1 is 3. 4 is greater and it's negative, so our answer is also a negative. Number 2, we're going to change subtraction to addition and change the sign of the second term. We're going to look, are our signs same or different? We have a negative and a negative, so that they're the same. So that means we're going to add. So 5 plus 2 is 7. And because it's negative, we're going to keep it negative. So negative 7. We have 6 take away negative 5. So we're going to change to addition. Change to positive. So we have a positive and a positive. And when we have a positive and a positive, we add, or when we have the same signs, we add, and it's going to be 11. I want you to pause, and I want you to try these 3 on your own, and once you have these 3 done, I want you to unpause the video, and I want you to check your answers and see if you did it correctly. Did you pause it? Okay, so here we go. we're going to, we have 3 minus 12, so we're going to do 3, change subtraction to addition, change the sign of the second, follow the rules. Same signs are different. Different signs, subtract. So 12 take away 3 is 9, keep the sign of the bigger number. Take and change subtraction to addition, change the sign of the second. Different signs mean to subtract, so 13 take away 8. That's right, 5. Keep the sign of the bigger number, which is 13, and it's positive, so our answer is positive 5. 5, change to addition, change the sign. We've got a positive plus a positive, so that means we're going to add. And because they're both positives, our answer is also positive. So hopefully you got those correct. If you did, give yourself some little check marks. Good job. Alright, I want you to pause the video again, and I want you to check your answers this time, after you've paused this. Okay? So you should have gotten 5. You should have gotten negative 8. You should have gotten negative 6. You should have gotten negative 23. You should have gotten 18. You should have gotten 0. Okay, here they want us to match by changing the signs. Like, what should it be and matching it with our letters? So it says match the subtraction expression with the corresponding addition expression. Explain your reasoning. So how would we change this one to addition? That's right, we change the sign to addition. We change the sign here. So 9 plus positive 5. So D. We change to addition, we have to change the sign. So negative 9 plus negative 5. So C. Negative 9, change to addition, change the sign. So negative 9 plus 5. A. And then change to addition, change the sign. Oh, what did I do wrong? Nothing. Here it is. Ah, sorry guys. There it is. I was looking at it wrong. I was like, oh no, we didn't have one. But there's our answer. Okay? Alright, example 3, modeling in real life. It says, which continent has the greatest range of elevations? Now this is important. Range. Where have we seen range before? We have seen range in statistics last year. Last year at the very beginning, we talked about statistics. We talked mean, median, mode, and range. Can you remember what range means? That's right. Very smart. Range means the maximum minus the minimum. So anytime we're talking about distance or the spread of a number, or how far apart numbers are, we're talking about its range. And when we define range, to calculate range, we have to do the maximum minus the minimum. So, starting with North America, we have 6,198. That's our highest elevation. That's the maximum. Take away the lowest elevation, which is negative 86. Following our rules, we're going to change subtraction to addition and change the sign of the second term. So now we have 6,198 plus 86. 8 plus 6 is 14, carry by 1, 10, 8, 18, 2, 6. So I get 6,284 meters as a range of elevation for North America. For Africa, we have 5,895. Take away the minimum, which is negative 155. So following our rules of subtraction is actually adding the opposite. Okay, so now we have 5,895 plus 155. So we get 10, carry on 1, 10, 5, 15, 10, 6. So we get 6,050 meters. Which one had the greatest range? And that would be North America. So as a recap, when we are subtracting, we're actually adding the opposite. And so if you can remember that and then remember the rules of addition, then we'll all be good to go.